Hello, my name is Rich Howard, owner of Architectural Builders Supply. This video is to bring you a closer look at the Rixson number 147 1.5" offset pivot. We're going to be looking at a left hand and a 626 satin chrome finish. And let's take a look at the hardware. I have it spread out over here, and we'll work our way from the bottom up, I suppose. So first of all, the floor plate. We'll go over some dimensional properties on these pieces, then we'll talk about why you might be looking at it. Overall depth, about 2 3/4. Overall width, 2 3/4. Then you're going to have your bottom spindle. That's going to fit down into this bearing that's here, just like that. Then your arm will come in and secure to that. That's what's going to carry all the weight, all the load of the door. Everything will be transferred down right to this point right here. That's why pivots are great, because you can hang obscenely heavy items. Rixson makes something that will handle 3,000 pounds as a pivot, and we've sold those, and they're epic. The 147 and 1.5 inches, we'll talk about its weight capacity. It's greatly reduced because it's 1.5 inches, but nonetheless, it's a smart design because the weight is born down here on Earth. That's where the weight is born. With this, you're going to need an arm. Here's the arm. This arm will go either left hand or right hand. This is also the arm of a floor closer. And so what happens here is you're going to have a situation not unlike that. Okay? You'll tighten that set screw, that very large set screw, that will connect you right to that spindle. That door is going to swing. Okay. This arm, just some basic dimensional properties. It's large. This pivot weighs about 5.5 pounds, all of it does. About 8 3/8 overall length, 1 inch. It's probably a good 3/8 thick. It is. Okay. Hole drilled and tapped there for that set screw. Okay. Then, before we get to the top pivot, there are... Whoa, didn't know that bag was open. Okay, so in here are lead anchors. 3 lead anchors and 3 machine screws. I would very much encourage you to use those for your bottom plate, assuming you've got the floor condition. And then you'll have a couple of these, I think it might be called walled rings, these C rings or E rings is I think what you'll hear them called. These are basically shims is what they are. You would be able to use these right here. You'll push that on here, and then your arm will sit on it. And I will tell you how thick they are as soon as I put these screws back. Why lead anchors? Why not just wood screws? Well, you're going to get wood screws with this. You can secure it down with wood screws. But when you get into when you get into pivots that are rated for heavier doors, 1,000 pound, you're no longer dealing with wood screws to hold it together. You're pouring that into concrete. 51, so or 52 thousandths. So you're going to be able to shim this upwards of 100 thousandths. There should be no need for shims. We'll talk about that. Okay. Then our top pivot. This is I believe this is a 180 1.5" offset top pivot. It's left hand. These 2 plates separate from each other. You've got your door portion. You've got your header portion. The door is going to swing right out like that. Overall width, about 4 1/4, or length. The depth, about 1 inch, 1.8 inches. Thickness of each leaf, looks like it's closer to 5/16. Well, it's 3/8 again. Now, I've said 1.5 inches a couple of times. What does that mean? Well, there are 2 different types of pivots, and they're center hung and offset. Let's discuss that and why you might be looking at this pivot. Let's do that now. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. So as I just said, center hung and offset pivots. It's all to do with, everything to do with the vertical axis of pivoting, the imaginary line between the top pivot and the intermediate pivots if it's offset, and then down to the bottom pivot. If it's center hung, that imaginary vertical axis of pivoting is down in the center of the thickness of the door. Okay, here's your door, 1 3/4, let's say, 7/8, right in the center. It can be at any point, not any point, but it can be at any point off the jamb, but in the depth or the thickness of the door, it's generally centered in that. I have seen them offset in an unusually thick door. I've done that personally when we were trying to cheat into a door, not only a center hung pivot, but other hardware like weather stripping. And that worked out just fine. The door wasn't obscenely heavy. The other type is center hung. Pardon me. As I'm saying the words, I'm like, that sounds familiar. The other type is offset. That same vertical axis of pivoting is now not down through the center of the thickness. It's measured off the face of the door to that vertical axis of pivoting. There's two. There's 3/4 inch, face of the door to the center line, and then there's 1.5 inch. 1.5 inch. Why would you want 1.5 inch, which is what this is? Well, generally because you're doing an application as if it was a wide throw hinge, meaning you need to move the vertical axis of pivoting out so that when you get the door to 90, that's fine, but you really want to go past, like to 180 degree. When you move that vertical axis of pivoting out, you can get that door out and around something rather than just around something, maybe not around something. Imagine if you had a 8-inch block. Well, 8-inch block. You've got block and then you've got face brick. That frame is inset into that opening that's going to be otherwise, 11-inch deep. And it's biased towards the inside. So now in your head you're thinking, yeah, I've got that outside corner of that finish of that face brick. All right, I want the door to go past 90. What do I do? Well, you move the vertical axis of pivoting out, is what you do. You use either a wide throw hinge or you use a pivot with a greater offset, like 1.5 inch offset. And you have to do the math. You have to lay that out in your head and have an understanding of, well, we'll use the top pivot. It's a little bit easier at this point. Face of the door to the vertical axis of pivoting. Face of the door to the vertical axis of pivoting. You want that to get out, that's 90, but then around. And all in this area is where you have something projecting, like your face brick, okay, out in here before your frame really starts, which would be about here. You've got something happening here, and you want that door to come out and be parallel. I'm going to show you a drawing that the client sent me for this exact job, which illustrates this point perfectly. The other reason that you'll use it, and the time previous to this, which I used with a pivot hardware from a different manufacturer, but same stuff. Client had 1 3/4 thick doors, and they applied to that material 3/4 inch MDF base to the door and to the frame. Well, to the frame and to the door. And the client says, I want to use the client says, I want to use concealed hinges. No, you can't do that, because what'll happen is when that concealed hinge, because it's weird, it's odd, floating vertical axis of pivoting, you won't be able to turn that door because that applied base is going to hit the applied base on the wall unless you miter that back. But even at that point, you'll only get to 90 degree. Client said, no, I need to go to 180 degree. Okay, then we can't have concealed hinges. Okay, fine. What do I have? Well, two things. We've got an 1 3/4 door with 3/4 inch base applied to it. So that math is in my head. Oh, that's working out well. An offset pivot, and I explained to the client, you're going to see a little bit of the hardware, not too much. I mean, yeah, you're going to see some hardware, not too much. We ordered it in a white powder coat to match his white doors. Is what we did. Inch and 3/4 door. Standard 3/4 inch pivot would be offset pivot would be standard, but now we got another 3/4 of material applied. Okay, all we needed to do was to get our vertical axis of pivoting out far enough to swing that door to 180 degrees to account for that applied molding. So I went with an 1.5 offset, 3/4 greater than the standard, to allow him to get that arm underneath the door. Had we used a standard 3/4, he would have had this very, very close or encroaching into that applied MDF base. Well, that's no good. You can't screw to that at all. Okay. And that was how we were able to solve that problem, to get the door to 180 degree, based on the fact that we had greater, material applied to it that we didn't want to try to mortise to. Let's switch to the screen view and let's take a closer look at all of the supporting documentation, some images, and then that client's drawing that I just referred to. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Here's the item that we're working on, in a 147 1.5 inch. Let's look at our photographs first. Here's our box. That's everything in the box. Your instructions, your template, your screw packages, your shims, bottom and top pivot. There's your bottom pivot with the bottom spindle. Assembled. Let me back up. You'll notice here a little groove that's cut in there. That's for your shims to go into should you be using those. And you don't need to. You won't need them. You just need to build the door to the proper size based on your finished opening. There's your arm. It's rather crude, but you don't see any of it. And I realize what we're missing here is the arm cap, and I'll show you that photograph in a moment. That arm cap's going to cover all of that with a screw on top. Our top pivot, then separated. Looking at the header portion as if we're looking down. Our fastener package, our shims. Now let's take a look at that header cap, that arm cap cover. And then here it is. That's just going to go right down onto the arm and secure right down to the top of the arm. Now switching back to our item, let's take a look at the application that this hardware is literally going to. Here's our client's drawing. What do they have here? Something. What is something? They have a 380 amp meter. It's not the volts that'll kill you, it's the amps. And that's a lot of amps. So, this is clearly a commercial application with 380 amps. You have this L-shaped door. I'm not sure what this is. Maybe just an architectural detail. This L-shaped door. What the client wants is that L-shaped door to swing out, allowing access to that panel. And here's what it looks like. This is the door, this L-shaped door. Here's the reference to our pivot hardware right here. You can see in the dashed lines how that door is going to swing. This is literally the 1.5 inch offset. And this client was extremely talented, was able to determine exactly the offset that they needed to get when that door is open. And obviously the door will hang off in this direction. But get it to clear that area right there. Client did a great job speccing that out. Great job. They didn't ask for guidance or assistance. And there you go. That's what it looks like. That's this application. Now, there are a series of documents that we're going to get to. All of the extended description information we'll get to in those documents. So in no particular order, here are the installation instructions. Let's do a particular order. Let's do the cut sheet first. And we'll do the product catalog next. Here's the cut sheet of our hardware. It's a 147. 600 pounds, when it's a 3/4 inch offset, it will drop here to 350 pounds when you go to 1.5 offset. So still a lot of weight that it'll hold. Doors up to 4 foot wide. Does include a 180 top pivot, as I said earlier. This would be a 180 1.5 is what this one would be. The door must be beveled to use these larger pivots. They want to see a bevel of a typical 1/8 inch bevel or 3-degree bevel. The bottom pivot mounts directly to the floor, allows door to swing 180 degree, trim permitting. And offset, is used to compensate for that. It's the same arm and cap as a 27 floor closer, which I believe is the same arm and cap. Now, it might be the same that was used on the 25 closer as well. Non-ferrous base material, which means you're only going to get up to a 20-minute fire rating on this. Means it's made of brass. And now, intermediate pivots. An appropriate intermediate pivot might be the M19 and the appropriate offset. This client actually ordered an M19 1.5 offset. For doors over 60 inch, you'll add an intermediate pivot. For every 30 inch after that, first 30 inch, after 90 inch, you'll add a second one. And then for every 30 inches after that, you'll add another one. That's what the textbook says in terms of this material. You can do extended spindles as well. Why would you need an extended bottom spindle? Well, because you have a flooring condition. You might want the length of that spindle to simply be greater because you're going to come over it, and with some flooring. You want more of that. You need more length to account for that, or maybe an unusual clearance. And interestingly enough, I just paused this video because I took an order from a client for this door. The client called me 10, 11 months ago for this, and that was in 2020, and the COVID pandemic put a halt on all of this work. So this client's going to take this door, literally, this call, I just took this order for this door, which is currently a left-hand reverse, this homemade door, which looks great. All of these hinges that he used, and he said, boy, I don't care for those hinges. The door, he says, the door doesn't hang right, is the bottom line. And what the client complained was, there's plenty of hinges to hold this 250 pounds or whatever it is. The trouble is this: when the door gets to 90 degree, out here, it literally takes the jamb post and pulls it forward. And then the bottom of that door hits the ground, and it doesn't open very well because all of the weight is transferred to that jamb post. My suggestion to the client was, well, you're going to want to pivot that down to the floor is what you're going to want to do, not hang the weight off the jamb. He says, what do you mean? I says, you need a pivot. He says, well, before you tell me that, I'm going to reverse the swing. I want it to close up against the house. I says, well, that'll work for me. And he just literally ordered a 147 3/4 offset, which will be anchored down here and the top pivot here. So all of that weight's going to be borne on the floor, solving this problem perfectly. These are spring hinges, actually. 10 of them, 2, 4, 6, 8, 9. 9 hinges, and that's probably just 8-foot lumber. That's probably what that is. The hinges will handle the weight, even though spring hinges aren't meant to be load-bearing at all. But that weight of that door pulled that jamb post and tipped it forward. Moving that pivot point here, resting all the weight on that concrete, on the earth. That'll solve that problem for sure. So very coincidental that that client called at that time. Optional features, 1.5 offset. He went with 3/4 offset because he had a very wide lumber condition at the bottom. He doesn't, didn't really need to center that further in. The fact of the matter is he's literally only going to 90 degree, as you can see. So no reason to really confront that. And you've got 600 pounds of load capacity rather than 350 when you're working with the 3/4 offset. Now the product brochure, I'll leave this up to you to discover, but it's going to go with offset pivots, followed by more offset pivots, followed by more offset pivots, intermediate, and then electrified, and then down to center hung. But what I want to show you in this is that's basically what we're working on. This client, literally, this assembly, 1.5" offset. What I want to show you is the catalog definition of the difference between offset and center hung, and it's right here. Center hung, the dimension from the face of the door to the vertical axis of pivoting, that's the offset. And when you do center hung, you don't have that. The imaginary lines right down through the center of the thickness of the door. If for no other reason that you dive into this catalog, do so to read those definitions. It'll make it quite clear what you're dealing with. Some encyclopedic, and then they get right into the meat and potatoes. Speaking of meat and potatoes, let's look at the template first, not the installation instructions. Here it is. So we're doing a 147. A 147, these are easy. These are really easy. What Rixson gives you here is a lot of dimensions. You need almost, depending on what part of the job you're doing, you unlikely need all of them, and that someone else may need some of them. It's unlikely that the same person needs all of them. And what I mean is, you need to know the size, the length of the arm, the width of the arm. You need to know the location of all the screws, but unless you're drilling and tapping reinforcements in a steel structure, you don't probably really care where these holes are because you're going to mark them right off the arm most likely when you pre-drill. So to go about installing this, and once upon a time there was no such thing as installation instructions with Rixson. It was, here's the template, and you don't need anything else. I said earlier about the shims that you shouldn't need them, and you shouldn't at all. And here's what I mean by that. You have to determine your finished opening size and how that will dictate your finished or your net door size. So your frame finished opening width and height is going to tell you what your net door height and width need to be. So dealing with the width, that's super easy. Just figure an 1/8 of an inch margin on either side, even though the template clearly calls out 1/16 of an inch in here. Figure an 1/8 of an inch. You want to go with the template? Go with the template. 1/16 of an inch. Over on the opposite side of the door, you're going to do the same. You should have an 1/8 of an inch though. Maybe from the finished opening width to your net door size, go finished opening width less 3/16. That would be your net door width, and you would divide that margin, 3/32 of an inch, equal on either side. That's based on the fact that you must have that beveled edge, and they're calling it out right here. That's a 3-degree bevel. They also want you to chamfer that inside edge as well, because what's found is that will make contact with the face of the stop. And what that will do, depending on the installation, it will cause a sound. You'll actually hear it as the door closes. You'll hear some squeak sound when it's not chamfered. And you don't want that, so you need to chamfer that edge of the door. I keep saying chamfer. I mean to say round over. They want a 3/16 radius there. You can chamfer it, of course, but that needs to be broken. That edge needs to be broken there. 1/8 of an inch from the face of the door to the face of the stop. That is not typical hollow metal work. You generally would have a little bit less than that. But when a door manufacturer is making a door and frame for this, they've been given the template, so they're making it to this. So now we know the width. Let's say 3/16 based on beveling both sides, less than your finished opening width. That's your net door width. The height, that's what we have to work on. Now you're going to see over here where you have to cut a notch in the face of the door. That's for the arm to breach through, the arm cutout, which is 1 3/4 inches. You know the length of the arm, you know the width of the arm. What you don't know is how deep to mortise it. That's directly related to the undercut, that's directly related to the clearance that you want to achieve. In this example, if you want a 1/4 inch clearance, the bottom of the door to the top of your finished floor, you're going to mortise 1 7/16 deep. Okay? That is a direct relationship between how deep you mortise this for the arm and how much clearance you want here. If you want 1/2 inch, well, make it 15/16 here. It's that simple. A 1/2 inch threshold, they want you to mortise that 1 inch. 1 inch deep. To give you a 1/2 inch threshold. Allowing for 3/16 from the top of the threshold to the bottom of the door. Pretty typical. So when I say you shouldn't need the shims, you shouldn't, because you're going to figure out what your clearance is. You're going to take this relationship between 1 7/16 and a 1/4 inch and just manipulate your door mortise depth based on what this changes. So if it's 5/8, okay, great. You know, reduce that value by 3/8 of an inch. I'm sorry. You know, I realized I said that incorrectly earlier. Not 15/16. That needs to be 1 3/16 deep if that goes to 1/2 inch. If you want the clearance to be 1/2 inch. I took a 1/2 inch here. I'm sorry. That's already calculating a 1/4 inch. So you're just going to plot that out, and that's how you'll come to that dimension. When you mortise it to the right depth, after knowing what your net door height needs to be, you'll have your clearance, and then you'll have 1/8 of an inch from the underside of the header to the top of the door. Then you have your net door height. You will not need the shims at that point. You do know the other thing that you have to know is that your arm cutout is going to be, as we said earlier, 1 3/4 inches wide. You're going to leave a 1/4 inch here. Then you have to know your offset. It's 1.5 inches, so that you know that the vertical axis of pivoting to the center to the face of the door is 1.5 inches. That's going to inherently tell you where to position the arm in the bottom of the door. Then they're going to give you the length of the arm and the width of the arm. Your top pivot is the same logic. You have to breach through the face of the door or the pivot itself, but they give you that dimension here. Where? They don't do so directly, but it's 15/16 to the center line, and then 7/16. So 7/16 plus 1 5/16. I think I said 15/16 earlier. 1 5/8. 12. No, 1 3/4 should be the width of that. I can put my tape measure on the actual pivot to know. Yeah, 1 3/4 is going to be perfect for that. 1 5/16 plus 7/16, 1 3/4, or 1 12/16. The thickness of each of the arms is 5/16. Of the pivot is 5/16. That's how deep you go. You've got the length. You've got the width. And that's why you probably don't need all the dimensions, but that's why installation instructions are, do you need them? Well, I suppose. It's nice to know. And I won't go over all these steps because, you need to drop a plumb bob, to make sure that you have that completely accurate. 1.5 inches from the face of the door, 13/16 over from the jamb. That's called out on the template. Got to make sure that you get that completely level. And the only thing I'll point out is you'll have the bottom arm screwed to the door. You're going to have the bottom plate and the spindle secured and set in place. The arm is ready to go. It's attached. You're going to have the header portion and the door portion of the top pivot attached, but you're going to remove the hex cap screw and draw the pin out. You're going to take the door and set it down on the bottom pivot, then tip it into position, and with the door pretty much in the closed position, you're going to push your top pin back up and then secure it with this hex cap screw. This hex screw that's here. This decorative cover cap is what it is. And that is how you hang these. So people will call me and say, boy, I've got a pivot. I can't figure out how to get this out of the opening. And it's because if you remove all of the screws, you kind of still can't slide it out. You're going to get to that cap. And you're going to remove that cap. That's on, and you'll see it on the pivot itself. Actually, because the top pivots are non-handed, it's on both sides. You can remove either side. And it's just literally right here. That has to be removed. You pull that out, you remove that cap and you pull that pin and there's no intermediate pivots, that door is ready to move. So be careful. The first time I replaced a Rixson floor closer, luckily I had my apprentice with me, and it's a two-person job doing that. This was a 3690 door, so it was not light. And that's the installation instruction. So I'm just going to leave that for you to discover and to review and study, but that's the short version of all of that, in my opinion. Now there's a link below this video as seen here to the manufacturer's page, and from here you can pull up not only all of the Rixson products we sell by means of this horizontal navigation, but also a link to the manufacturer's website, as well as a link to the full product catalog. I'll leave you to discover that as well. Not only pivots, floor closers is the other thing that Rixson is known for. Overhead stops, holders, electromagnetic door holders as well. Speaking of catalogs, I've got some old versions of them here. I've got one from 2010. That's fun. Well, I've got one from 1920 as well. If you want to see what Rixson was making over 100 years ago, that would be your document. Now, I don't know how long Rixson's been in business or a company, but it's definitely 19th century. We repair Rixson material, and generally it's floor closers that we end up working on. I'm not aware of really, they've got overhead closers, but I don't believe we've repaired any of those. Our record for a Rixson floor closer repair dates to 1904 in a bank building in New York City. Lots of Rixson in New York, that is for sure. They were in Franklin Park, Illinois for many, many, many years. I've driven past the old plant countless times. And now they are somewhere in the Carolinas, I think, is where the manufacturing is. Let's wrap up this video on camera. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Now, when I am at a training class in Canada with my Canadian counterparts, Rixson floor closers are not used in Canada at all. They don't ever see them. It's because of I'm from Chicago, so I get the dreadful cold. The fact of the matter is it's cold for so long, for so many days, that fluid just doesn't survive, so you don't ever see them specified there. Fun fact about Rixson floor closers, I suppose. The opposite side of that is you're going to see Rixson floor closers installed for decades, and a lot of people will shy away from speccing them or installing them or paying for them, even when the application really, really demands it because of the initial upfront cost. Well, I would say to that person, we routinely repair closers that are 70 years old. If that closer cost you $2,000 today and you knew that you were going to have to work on it again at the year 2090, what's the cost per year? It's less than a cup of coffee. There's no way that you're going to get the same sort of lifespan out of a surface closer. So while floor closers are expensive up front, they are the cheapest piece of hardware that exists when you consider the lifespan of what it is. Floor closers are very common in retail. Clean sort of look anytime you're at retail application. This store, it's always floor closers on those glass Herculite doors. We've had people from Korea send us material to be repaired or to be replaced. So I'm a big fan of floor closers, even though, yeah, they're expensive. And they take a lot of money to install them as well, because they're generally poured in concrete. Not generally, they're always surrounded in concrete. Anyway, I'm a fan of Rixson. I enjoy their product line. I enjoy learning about their product line. Their people over there are very helpful as well. Any questions on the Rixson? This is the number 147 1.5" offset, or any other Rixson product. There's that arm cap that goes there. Or any other Rixson product, please feel free to reach out to us. And thank you. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up. Please subscribe and maybe even send the video to someone that you know. Thank you.